All right. Good evening. Welcome back to probably one of the last videos on the live streaming series for the Big Data Bowl. This weekend is the last days to put together a submission. So Sunday evening and midnight will be when I almost want to say the contest, when the last submissions are due. The goal for this session is I'm going to try and create some, I'm going to call them meta fields that aren't directly related in the data set. We're going to do some data manipulation and transformations to find fields that are kind of aggregates of information or meta in terms of they're referring back to the information that we already have in the data. A few ideas for what I was going to do with that was to look at a few things from right before that play happened. So what was the result of the play before it? Like, was it a run versus a pass? Was it the first play of the possession? Because that should give us a better indication, I would hope, for how teams approach their offenses. Also, the play before the previous play, what was the outcome of that? Just in terms of it being a run versus a pass. To give an idea on how effective the team is being in terms of mixing up its play calls, I would assume that there is going to be some changes in how an offense approaches based on their previous plays, right? You may see plays where a team or drives where a team has run the ball, 6 times and passed twice, right? Like they're running it. You'll hear the commentators say like they're running the ball down the other team's throat, where they still have to mix in pass, right, to help keep the defense honest, or when the defense is loading the box, take those chances to go over the top. But I want to see if there's any indications in the data that that would be true. So it may be that the offense has run twice in a row, and on that third play, maybe they're more likely to be passing. So not necessarily in terms of first down, second down, third down, right? They may run a couple plays. Let's say it's first, second down. They convert now on running the ball again on third down. On that next first down, are they going to be running again, or they're probably more likely to be passing at that point, or at least I would assume so. And so we want to see if that plays out here in the data. Another idea is to get like the entirety of the is it the first possession of the game basically that these plays are happening on. I'm wondering if there is, you'll hear a lot of times like, oh, a team will go into a game with a script for the first 10 or so plays. And then the idea would be that they've already run the ball successfully or run the plays that they wanted to run successfully to help figure out what the defense is doing. Now, are they starting to run versus pass more or not? So, like I said, these are fields that are more meta in terms of how the game is going and looking back at information that we already have in the data set. So we're going to focus on, we're going to make a field called, is it the first 10 plays? And then, is it the first possession? So is first 10 plays, is first possession. Then we're going to look at previous field. We're going to make previous play result. The 2 plays prior would be that one, or the play before that. And then, is it the first play of a drive? So just trying to get an idea of, are some of these binary fields going to help model performance? So we're going to come here. This was the thing we had built yesterday to go through each team individually. We're still going to keep that because we did get some better model performance. This way, there were a few teams that did not fit that mold, but in general, it seemed to be fairly helpful. So I want to keep that in mind. And so before these, I'm going to create a couple fields. So let's make a markdown field. We're going to call this adding meta fields. For the section, we want to use the data from within the game to try to improve our model. Is first possession, is first 10 plays. Let me real quick just check on the stream status. Yesterday there were a bunch of problems with going live and using Visual Studio when I was trying to do updates to the Pokemon stream. So I want to see if we're having those issues today. It does not seem to be the case. Let me just go through all of these. Do keep in mind that the data that we are accessing is all from the Big Datable, and they have provided a wonderful summary of all the fields within them. Think of each file essentially as a table we've worked through in previous sessions, joining these together to aggregate the data that we want for the game, its context, the game context, situation, information. So we're going to pull all those together here. So if you need to look for a specific field, or you're wondering what some of these fields are that I'm referring to, almost all of them, except for these couple of fields that we will be creating here, are already in the data set in some way, shape, or form. And so we've used them to come together. So first possession, first 10 plays, previous play, previous play result. Prior, previous, play, prior, previous, play result. And I'm using their styling to keep it consistent. You can see, like, when I typically will create things in the data set, I prefer underscores between them, but just to keep it consistent. That's why I'm kind of following their casing here. Is first possession and also is first play. And that should be all of them that I had. Let me look at my list of ideas here. First play. Yep. First possession. Yep. Okay. So we're going to go through and put these together. So I want to see here in there, is there a, yes, in the play data, there is a possession team, which already provides that information. So okay. Let's work off the play data of plays. Let's go here. Plays. right, let's work off that. So let's take plays. I want to sort. And there's a few columns that I want here. I want the game ID. I want the play ID. I want the possession team. This is going to go through for each game. Then reset. This. So now let's just call this plays sorted. And if I look at that, in our data, is there a time? Yeah. Oh. Play ID description. Let's go this way. Quarter. Game clock. Now, if I do this, great. Great. So now I can use the is drop back to indicate whether it's a pass play or a run play. Great. Okay. So what I want to do is let's create previous play. For play in plays sorted. Oops. So essentially, I'm going to iterate over the whole plays sorted. At previous play equals. But we're going to put an if here. If plays sorted at is dropback. Is dropback is the field name, right? Yeah, is dropback, no spaces. Is dropback. And that should be true, right? Yes. Equals true. I have to shift this one, don't I? I do. Got it. Okay. I think that changes the approach slightly. Let's do plays sorted. Previous play result equals plays sorted. Then I want to group by the game ID, the possession team. Then yards to go. Shift 1. So this shift 1 is what allows it to, it'll go through the process. It'll group all the data on the game ID and then the possession team. So we'll look in each of those groups, and it's going to look at the yards to go, and it's going to shift 1 back, basically. So if you look at this row here, Josh Allen pass right. Should see the yards to go. It's going to look, the first row I have nothing to look back to, so it will say 0. Actually, instead of yards to go, let's use yards gained. I don't have to calculate anything additional there. Yards gained on the previous play. Then plays sorted. Previous play. Let's just call this previous play type. I like that better. Previous play type. And I want to go plays sorted, group by game ID, possession team, the same as before. I want to check the is drop back. Then I want shift 1. So if I put these two fields in, let's see now how plays sorted looks. So come over here, right? Previous play, there's going to be none. Please play result was 6 yards and it was a drop back. That's true. We know that here. Same thing. This is looking back to this field. This is looking back to this field. Perfect. Now, we want to look at the prior 2 plays. So it's going to be the same process. Actually, let's just copy these right here. Right? And we want to call this the prior, capital P, previous play result, prior, capital P, previous play type. We're going to shift 2. We're going to generate those. And what you should see here, guess what? These first 2 are now nulls. And so with the true or false, we know if it's a pass or run there. So we've really quickly got 4 of these fields that we wanted to create. It's not all that challenging. Again, the thing here is knowing how shift operates. You do need to group the data into essentially how you want to subgroup and look back. So for example, I wouldn't want to put the play ID here because you would get essentially not a number for everything, because the play ID is unique in the context of having game and play ID together. But because I just have the game ID and that team, the possession team, that means I'm only looking, for example, at Buffalo's plays. Even if I get 40 plays along here, it's only looking at Buffalo's plays. It won't, I don't know who they were against in this game. Let's just say it's Cincinnati. It won't include what Cincinnati was doing. Cincinnati would have their own group because they're a different possession team. And then it's only looking at the game. So if we were to find another Buffalo game that's different against Cincinnati, let's say they're against the Jets, the first play of that game would come back as this prior or previous play result as not a number. And that is what we want to have happen. Now, for how we're looking at the how we're going to look at the first play and the first possession is a little bit different. So it's a similar process, but it's going to play out a little bit different. So let's go call this plays sorted. Let's call it is first play. Okay. We're still looking at that plays sorted table. We still want to do our group by, but now we're only doing game ID. Because what we're looking at is the possession team in the group, or sorry, as the field. And I want to shift 1 and make that an int. So I'm going to run this, and we're going to look at plays sorted. Where is oh, I jumped ahead of myself. I'm going to do this. It's not equal. So I'm looking at the possession team, and I'm comparing it against the previous one when it's grouped by that same game ID. We're shifting it back 1 field so that it does this comparison, and then we're returning that as an integer. So we're making a comparison. If it's true, it should now come out, I believe, as 0. So see here, first play of the drive is now 1. And then it looks like here's 1, I guess, towards the end of the game, maybe. Yeah. So it was Baltimore's ball. Now it's flipped. It's now New Orleans' ball. And so one final possession, or one final play, well, not final possession. And so that's working the way that we want it to. Now, if you want to clean these up a bit, right, you don't like the not a numbers, what we can do is I wouldn't give it a 0 because I'm afraid that it will create confusion with others. So like the previous play type, you either have true or falses. Setting any other value here is fine. Same thing for the previous play result. Right, we want to take this not a number. I need to think a little bit about how I want to approach this. Setting this to any other value is fine. So if I take, we'll deal with those first. Previous play type. equal previous play sorted. Previous play type. Bill and A. Call this first. And we're going to do the same thing, except for that previous play type. Prior previous play type. Now look at this. First. I think those are fine. Still want to look at what do we want to do with the prior previous play result. I don't want to say 0. I don't know that I want to say negative. Because I don't want to leave it as a 0. I don't want to leave it as not a number. I don't want to put it as a 0. Let's just say that these are the first play of the game. What to do? You could set it as a mean. Let's do, I'm going to set it as a really small number. So all these are like 6.0. I'm going to set this as like 0.01. So go here. Bill and a 0.01. I don't want to set it to a large number that creates influence in the model. I don't want to set it to 0, as I feel that that would also create confusion with plays that actually did not go anywhere. So we're going to set some really small number. Theoretically, it could take this out to be a bunch of zeros and then a 1 to be effectively 0, but not 0. But I want to approach it that way. And then right now we have the first play, the previous play type and result, and the prior. But we need to make these is first possession and is the first 10 plays. So how we do that is going to be very similar to how we approach this first play in terms of doing the first possession. So plays sorted. We're going to call this is first possession. Similarly, it's going to be doing that same comparison. So we're going to do plays sorted. So I want to group first. Sorry, group by the game ID and the possession team. Then I want to look at the is first. They kind of feed into one another. Transform max. Create that, and we're going to look at it here. And you can see the first possession. Oh, but it's doing for every... Is the first play of the possession is different than the first... Okay, so it's not exactly what I wanted. Let's try this. We're going to do a cumulative count of the possessions. And if it is less than or equal to 2, then I'm going to say that that is the first possession. Right, so one team has the ball, then the next team gets a chance with the ball. And so if I come over here, what happened here? Okay. I need the count of is first play. And if I look at that, so if I group it by game, the possession, right? I didn't see. This is the next play here. So the fourth one should be part of that possession. Okay, let's look at the first 10 fields and see if that helps me think about the first 10 plays. And see if that helps me think about the approach to this one. So this one is plays sorted. And I want to group by game ID, possession, team, it should be then counting the first 10 plays as type integer. And let's see how that comes out. First 10 plays, great. These should not be, it seems fine. first possession, though, is not. Let me think about this more. I'll use this chance to check. If there are any questions, please feel free to ask in the chats. So his first play. Works correctly. We're looking at the previous possession team. Now, if I look at plays sorted, group by game ID, possession, team, and his first play. What do I get? Oh, 2 S's. Show display. No. I guess let's just look at the cumulative count. Maybe the issue is this. It's going to take a moment to load. I want to see here. Oh, they're not in order. Well, damn. So we go here, plays, sorted, and I want the first. It says at row 8, we get a change. So give me the first 20 rows. Right. Let's see here. Okay, so this gives me the index. So I take this and I'm plugging this in here. And now I'm looking at plays sorted. I set it as type int and it did not come through. And then I want to fill down essentially here. As type int. I did not do that. So let's see, Python data frame, build down. Fill. So I go here, plays sorted, is first possession, fill, access equals 0, in place equal true. Now we come here, first possession, and that's 20. Devin Singletary, so Buffalo's back on offense, and it's no longer the first possession. Perfect. All right, so we've got the columns that we wanted. Right? We have them in this place, sorted frame. But now we need to merge it back into this rush def data. And so to do that, rush we're going to call this rush data enhanced pd.merge. We want to join rush def data with our new play is sorted. And I don't need all the fields from this, so that is why I'm going to say game ID, play ID, and then the new fields that we created. So is first play, is first 10 plays, is first possession, I'll bring this down. Just previous play result, previous play type, prior previous play result, and prior previous play type. So those are the 7 new fields that we created. Do this on game ID, play ID. How is a left join? Should be good enough. But then we need to go here. And now this is all going off of the Rush Data Enhanced. Boom, boom, boom. Nothing else there. Great. Now, we added those fields to be merged, but we did not include them into the model yet. I'm going to bring this down here. So that all these fields are coming through, we are going to treat the we want the previous play result to come here, and the prior previous play result to be here as well. Let's speed this to the model. Rush data and hit. Oh yeah, because I did not run this. I was right. Double crack this. Since this worked. There. And so we won't need that here throwing us errors. And let's see. Less than not supported between instances of string and Boolean. It's there when it's getting to the fit. No, predict. The train. Yes, the fit step. Hold on a second. So we grouped everything together. Rush, data. Hence looks like a what? Is first possession. Prior previous play result is 1. That should not be possible, right? I suppose it's not ordered, so it doesn't matter. Let's rebuild this. Everything's filled. Okay, so I guess I just did not run it correctly. Or after we put in the fill NAs, I don't think I ever ran it. Hopefully that is simple enough. No, it's not those. Rather to either be a boolean or a string. So it's thrown for a loop by the previous play type. Okay. All right, let's do this. Plays sorted. Previous play type equal true. Previous play type equal pass. Let's just make sure that works. I guess the better way to handle this would be for play in range length plays sorted. If at previous play type play is true, right? Then this we're now setting to pass. Else No, not runtime error. And then we're going to look at the previous play. If plays sorted at play what are you doing to me? So previous play result. No, previous play type is what I'm looking for. So previous play type is true. If I do this, what do I get? 0. If I do this, I just have it backwards. All right, simple enough. Take these out. I'm going to copy this in. There, 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 there. Take each of these out. Will this now cause an issue? No, we are clear. Ooh, some of our models got significantly worse. Let's see. So it improved a model like Pittsburgh's, but it hurt us on Buffalo because we had nothing below 0.6 before. So if I take this, let's see. What do we got here? First 10 plays, the positive. It helped Buffalo. Did not help later in the game. First play helped when it was not the first play, which is great because that's more frequent. Is first possession. Not a good indicator, but helped with later ones. Motion since line set became a largely negative indicator here. Very heavily negative. So if I look at this, what do we see here? Motion since line set 0 was positive. Well, what am I seeing here? There's something that is large negative. The empty formation. Okay. Receiver alignment. Helpful except when it's a 3x2. Interesting. Some slight shifts here in the data now that we have indicators for the previous fields. It seems like the defending team became a stronger predictor in a lot of scenarios. There are a few here, it looks like it'd be about even. So maybe defending team doesn't affect the model. It adds a lot of noise. So I come back here. And I'm just going to take defensive team out. And let's look at this. Oh, interesting. So it helped us with a team like Buffalo, hurt us a bit with a team like Tampa. So real quick, this whole middle section is going to drop out. But some teams it was actually helpful in terms of their predictive model. And now let's look at what the new heat map looks like. If I go here, this is also going to shift. Now this is too large. Let's go 10 by 15. So knowing that there's a tight end, or knowing the information about tight ends is always positive. Knowing things about receivers and running backs is not particularly helpful. And 3 tight ends does not improve model performance. Interesting. The receiver alignment seems to generally be positive. Oh no, there's a few more here. Let me see. Previous play type when it's run is not a good indicator. The prior previous, in knowing either one, does not help our model at all. So knowing that is not helpful. Prior play type pass is a little bit helpful. Where's our first play? First play here tells us generally nothing. First 10 plays, when it's not the first 10 plays, it has a negative impact. knowing it's the first possession also seems to be negative. So first play, no, is negative correlation. And first play, yes, is a negative correlation. So that in general did not seem to help our model. First 10 plays, also negative in both. So let's drop those out and rerun the models. So we got here, yes, first play is first 10 plays. We're not helpful. I think I just shrink it. Yeah. So, how do we do? Well, Tampa Bay is no longer the most predictable offense. It's Seattle. And Buffalo is back down below the 60% cutoff line. So the prior previous information is also not helping. It's negative correlated on both. So let's drop those. Prior previous plate type. Rebuilds the model. We go through improvement here. Tampa has now regressed even more. That one's just jumped out to me. Seattle's still hanging above the 80. Cleveland, Arizona got better. Single back is no longer such a outsized performer compared to what it was prior. The empty formation is still, that was a good one to show that there. When we average it across all of the groups in terms of the coefficients, still the same thing. So hold on, where is my, I thought I had one that was, I thought I had a team summary, or using team summary to show each of them, but it does not look like it. Okay, let's go back. Team summary accuracy. %72% across those. So not as strong of a predictor as it was before. Disappointing. There. So it helped us with some teams knowing this information and then not as much on others, which I guess shouldn't be overly surprising. I think maybe the biggest takeaway here is that there's no one-size-fits-all model that would work well across all the teams. And it shouldn't be groundbreaking, but we have the data here to show that, right? The changes that we were making were improving, or just adding or removing fields, were improving some teams and significantly hurting others. And so you almost have to treat each team a little bit differently in terms of the variables that you want to include in your model. And we're at about time for today, but I think I want to come back tomorrow and see if I can come up with a way to iterate across the variables across teams to find better models for each team that are slightly different in terms of the variables that are those final combinations. I'm gonna say final with air quotes here. My guess is, and that's part of why I want to kind of take that one offline, is it's going to take a little bit of time to run through those. Not that the logistic model takes very long, but now I'm not just iterating across the 32 teams. I also have to iterate across the different combinations of columns. So for each team, I'm going to have to look at these different categorical variables. And the new fields that we created, and go through them, take one out, put the other in for them. And so it becomes almost a matrix, right? I'm not going to remove, was it previous play type? Or I need to remove them like singly. I need to remove them in groups. And so this gets kind of larger and larger as you go through the different variables. So I think it's going to be a bit of a challenge. What I want to do is do a little bit of research to try and see how others have approached this. I know when I've done something similar to this previously, you end up with kind of exponential growth in terms of the compute time. Now we're only working with a small data set, so it's a little bit less of a concern. But I would have to figure out how to go through and essentially create all the permutations of the fields, and then do that across all 32 teams, capture that data into a table on what were the combinations of variables and what was, the team, the combination of variables, and then what was the accuracies. And seeing if we can get further improvement there. Maybe for some teams, it's the simplest is best, and maybe for other teams, the more information you can get it, hopefully the more the better performance you can get out of it. So I would be curious how that plays out. So I do want to, like I said, spend some time on that approach, and I think I'll come back with that tomorrow. Whether we'll go through, we'll code the approach here, we'll get an idea of what it looks like and see what each of those key factors were for each of the teams. So we will stop there for today. I will set a stream for tomorrow to go through those iterations in the meantime, I know we had issues yesterday with the development for the Pokemon stream. What I'm intending to do with those is to run that offline for the course this weekend and try and come back to it with the improvements. What I had seen from the stream from last night till today was kind of disappointing. It was no longer, it was really struggling with Brock and knowing that Vine Whip is a super effective, strong move. It seemed to favor casting Leech Seed a lot. I'm wondering too, because I had set it to run here using the previous save state that had gotten the farthest, but that was using not using Bulbasaur, that was using Squirtle as its starter. And I felt like that could have been some of the reason why it had not performed as well. So I'm essentially going to have it start the training from scratch. I'm also having it do 1024 batches. We're going to run the... Actually, I'm going to try for 24 agents. I don't know that it's going to necessarily improve performance greatly, but the hope is that it should be able to do that. Actually, let's just say 20. And I hope that works out. Run those offline. It's going to be a fresh batch using Bulbasaur as the starter. I go through 10. You're going to have, what, 2 million steps? No, 200,000 steps, 4 million steps per iteration. I don't know that it's going to complete 1,000 cycles or 100 cycles of that, because then you're talking 20,000 iterations. I'll just let it be. So, because I don't think it's going to get that far with me coming back online tomorrow to do a stream, because I have to bring that offline to go through this. So I'll save this. I'll upload that to our GitHub repo to share out afterwards. And like I said, I'll bring everything offline. I'll set up a stream for tomorrow, roughly the same time, somewhere after 8:30, 9 p.m. And we'll go through this, and then really need to come up with that almost final presentation based on the findings here of what we had found so far. So thank you all for coming. If you are watching this video, please feel free to like and comment and subscribe, so that way you can tell me what's your interest. I think I've seen now quite a bit of interest on the data exploration. Today we did a little bit of meta exploration and creating our own fields for the models to use. And it seemed to have helped for some and not for others, which is about what I would expect, given that each team almost has its own personality or its own capabilities. So we'll pick this up tomorrow with, like I said, kind of the matrix approach of working through all the variables to try and find the best model for each team based on what we've built. And then hopefully that can bring us up. Like we hit about 75% for the overall average here. If we split each team out, we are getting cases where they are better, and there are cases where it's just not as strong of a predictor. So hopefully we can get better scores across there. Like I said, the mean of the accuracy, it's mean of a mean. So it's not going to be exactly the output of the model, but 72% is worse than we were at before. We're at 74%. So hoping that if we can find a better model for each team, we'll get better performance there as well. So thanks again for watching, and I'll see you all tomorrow.